All right, so for this question, we're solving for the value of Kc, and we don't know the equilibrium concentration. So we have to set up an ice table in order to solve for this. So set up your ice table with your reactants and products, which in this case, there's only two species present in the reaction. We've got N2O4 and 2 NO2. Set up your ice table, initial change, equilibrium, and then sub in the values that you're given in the question. So the information that I have is I know there's 2 moles of my product introduced in a 2-liter bulb. So remember, whatever you sub into your ice table has to be in moles per liter. It can't be in moles, or it can't be in grams, it can't be in liters, it's got to be moles per liter. So 2 moles of N2O4 divide by 2 liters gives us 1 mole per liter. So we can sub that in for our initial value. At the end, we have 1.6 moles remaining. Remember that we don't want to sub in 1.6 here because it's not in moles per liter. So just like the first value that we were given of 2 moles, we also have to convert the 1.6 moles into moles per liter. So 1.6 moles of N2O4 divided by a 2-liter container gives us 0.8 moles per liter at the end. So from this information, I can determine that the change is a decrease, so it's a minus, and it was a change of 0.2 moles per liter. Okay. For this column, for your change, the row that has the change values, this is where we can use the mole ratio to figure out the change of any other reactants or products. So my mole ratio here would be 2 over 1. So I would times this by 2 over 1 to give me the change for my NO2. And it's going to be an increase, so we'd write it as positive 0.4. I can fill in the rest. Initially, it doesn't say anything about having product present, so I can assume that it's 0. And at the end, I'm going to have 0.4 moles per liter. So if we set up our equilibrium expression to calculate Kc, remember Kc is always products over reactants. So we sub this in as Kc equals 0.4 squared divided by 0.8, which gives us a value of 0.2. So this means that the reaction is less than 50% and our products are going to be favored because my K value is less than 1 moles per liter.